Right. Good morning, everyone. How are you?
I'm doing good, Andre. Thanks for asking.
Thank you.
Good.
It's around 11:30, so I'm thinking about starting right now. It's being recorded, so those who are late can watch the video later on, and those who stop by or miss it, still there for them. Just want to say thank you for showing up. Welcome to the CSU Robotics Build Along event. I know it's a bit late in the year. I just want to hope everybody got the kit that I sent out. Was there any problem with that, with the mailing it in? Did everybody get it?
I got mine.
Yeah, got it.
Okay. So first off, I'm going to do a quick introduction overview of what the parts that were sent in. Everybody sure got about 4 or 5 main components. You had the Arduino Nano right here, along with the stepper motor and the driver, and the LED matrix. There was also a expansion board that you're allowed to mount the Nano onto that, and then use that as pathways and pins to different peripherals. Starting off, sorry, starting off with the Arduino Nano, so to get a basis so you guys have an understanding of what it is. Obviously, it's a microprocessor. It's mainly the brains of everything in this. For the Nano, we generally use the Arduino IDE as the program and upload programs onto a Nano to use to control different peripherals. Going over some of the parts and the main functions of the Nano. I'm going to bring up our slide. There's quite a few pins. Yeah, there are quite a few different pins on the Nano. Most of these pins are able to use for any of the data slides. Going off from 1 to 13 down here. Every one of those could be used as a connection to any of some of the programs. There are a few pins that have specialized functions that, while can be used for other functions, are mainly used for example, the LED matrix. Specifically, we want to use the SPI pins, that is pins 10, 11, 12, and 13. Those pins are more hardware orientated and allows you to send data and information quicker back and forth between different parts. Obviously, for the expansion board, we're able to hook that up and have pins. Sorry, lost my train of thought. Well, guys, moving on. After Arduino, our main parts that you guys are curious about is the peripherals we sent. We sent 2 of them. There's the stepper motor and the LED matrix. Starting with the stepper motor, you guys should know that this is one of the cheapest and easiest stepper motors you can buy for different functions. These stepper motors are also found in simple mirrors in a vehicle, help turn it, different functions like radios or accept layers. This specific one we are using is the 28BYJ-48 stepper motor. Also comes with a driver board, which helps us control the current to the motor from the Arduino IDE. As mentioned, this is technically the cheapest motor. Because of that, it's also not the most accurate. So while generally stepper motors are very good for specific functions, different steps, this one, since it's kind of cheaper, it's a bit off. That's okay. As an introductionary, it's good enough for you to use. A little basis about the stepper motor. Its main function, it uses current or electrical pulses to turn the motor. Since this is technically a 2-phase stepper motor, this is used by having each phase, a pair of them, turning on and off, driving the motor along the electrical magnetic field. Now you should know that stepper motors are actually able to do full steps and half steps. What that means is, since this motor is a 2-phase stepper motor, it's currently used as a full step. That means that each step is 2-phase used to drive the motor, but you can actually set this up to do a half step, which means that each phase is only done one at a time. Instead of doing a pair turning on and off, it does one at a time. Normally, a full step motor in this specific case would have about 2,000 steps. As half step, you can get 4,000. However, one of the drawbacks of doing half step is it loses about 30% of its torque capabilities. So it's better for accuracy, it's worse for torque. One of the reasons why we use a driver board with the stepper motor is stepper motors generally take a lot of current, and we need the driver board to help control the current, so it prevents us from burning out our Arduino board. Unfortunately, we did not realize this before we bought the parts. Because the expansion board that we bought does not separate the current or the power draw from the Arduino with the expansion board, we cannot run both the motor and the LED matrix together. It draws too much current and then one of them will shut off. So we have to do them separately. However, if you guys are interested, you can easily buy a plug-in USB cable where you can power the LED and the motor separately from the expansion board for any of your uses. Moving on to the LED matrix. Now, this little thing mainly is controlled by 64 different NOT gates. It is 16 inputs total. Each pair, if turned on, will turn on an LED. We decided to get one with a board onto that, specifically because it requires less connections from us. Normally, if we use just the LED matrix itself, we need to have 16 cables going each to a different data port in the Arduino. To prevent that and make it a little easier, we get with a driver board, only has 5 pins. Basic of it is the power, ground, data, the chip select, and the clock cycle. That makes everything a lot more easier to handle. I know you guys only got one LED matrix. Normally, you guys can actually get a whole bunch of them. In fact, you can buy about 3 or 4 of them together and do one massive block into a, for example, a 8x8 LED block. Cat them all together and then run them off power and Arduino, and you have a massive LED light board. Easily, you can do whatever you want with it. That's just a quick overview about the basis of the parts we sent you. I suppose I'm going to go over how to upload and program different code using the Arduino IDE. Let me pull that up quickly. Right here. If you go to the arduino.cc, there is 2 ways to upload code into an Arduino item. We can start off using Code Online. When you open that, you get a basic web editor, which allows you to upload code right out here. Compile it and upload it to an Arduino. There's also examples you can do, going from the basics, from the bare minimum analog read, bare minimum blink. Let's actually do that one. It has everything up there, explains what you do. Blink text. A lot of these programs, for example, if you go into, let's do display.
Hey, Andre, hold on. Can everyone read his screen, or is it a bit blurry for anyone?
It's pretty blurry.
Okay.
It's blurry.
Is there a way? All right.
It could be one moment. I'll try to fix that.
That's
that
better
any
on
better?
my end. Yeah.
Okay. Pull chat out. If there's any issues with any recording of the video, let us know in chat or just speak up. We'll fix it quickly. I might not notice something immediately. Where was that? Ah, yes. Using the online IDE, a lot of these programs actually require different libraries, which can be found right here under the examples. There should be, with the standard IDE, there's quite a few default ones that are pre-downloaded. Example, all of them right here. I personally found that using the online version of the IDE is a bit annoying. That's why I generally prefer to download the actual app, which you go back here and just download Windows 10. Right here. I'm going on the basis of the app, the desktop program. There are some things that you should start off to get your IDE reading your Nano. One of the first things is, since the Nano we sent you is technically a clone of the Arduino Nano, not the original one, the default IDE cannot read or pick up the microcontroller, so we have to download a driver for that. In the zip folder that I sent everybody in the emails, there is a list of different links right here. There is actually a link where you can get the driver, which gives you right here. You just have to download it. And then once you do that, your IDE can read your Nano. Moving on, to connect that specifically for our Nano, we have to go into board settings, Arduino, and pick Arduino Nano. And then for the processor, you have to go to processor and pick 18 mega 328p old bootloader. And then when we connect our Arduino Nano, hold on, where is my plug? With our driver, normally you cannot be able to read the Nano. But with a driver, when you connect our and the computer, it should show up. Actually, plugging it in right now. Yeah, there we go. It should say COM9. It might be different for you. Once you plug in your Nano, it should pop up automatically. Select that.
As a side note, if you ever have trouble uploading, probably pick a different COM port. That's most likely the problem if you know all your other settings are correct.
Yes, that's a good point. Did everybody play around the parts yet by any chance? Because I wanted to move on and upload some code and see how compliant and upload to some components. Or did no one play around with it yet?
I have not played with it yet.
I did not do anything with it yet.
I didn't want to mess it up.
That's fine. I was actually start out with the stepper motor. To that, I'll bring up the wiring diagram.
Does everyone have the Arduino IDE installed?
Does anybody need help installing it?
I have a question actually. With the different settings you're using with this fake Arduino, will it actually affect anything if I want to go back to an actual Arduino? Or do I have to just change the settings?
No, it should be everything fine. The only difference is if you use a actual Nano, you have an update one, you have to change it to this one. The port should be fine because that's default. maybe the processor. Some of the older Nanos and the operand ones need the old bootloader. Some of the new ones just use the new one. It's pretty easy to figure it out. If you upload something that doesn't work, just switch bootloaders.
Cool, thanks. That's all.
I just have a quick diagram of all the wiring I did specifically that will work with our code that we sent you. We have the basic expansion board with the stepper motor and the driver. As you can see here, that this stepper motor plugs into the driver right here. And then I have a bunch of cables. Everyone should have 11 female-to-female connectors. Pretty sure I counted that out correctly. Starting off, as you can see right here in this silk screen, that we have 0 to 13. Those are all the pins that can be found on the Nano. That's just connected to the actual Nano once it's plugged in. Right here, we have the power. The bottommost one, the black line, that is ground. If you look at the driver board, it is indicated by a minus sign with a dot over it. That is ground. The next to that, the red line, that's going to be your power. Plug it into the 5 volt right here, and the ground right here. Furthermore, this expansion board has multiple slots, so if you need more room, you also can find power down here. That's also 5 volts in ground. Below that is actually 3.3 volts in ground. Our stepper motor cannot run off that. It needs more power, so we have to use 5 volts. Moving on, you have inputs 1 to 4. That's the purple, blue, green, and yellow lines. For my specific program, I had that input 1, purple, is into 8, 2 is 9, 3 is 10, and then 4 is 11. Since most Arduino boards or Nano boards, it doesn't matter where you plug in the lines, specifically for the motor, you can just move this around easily in the code. Because right here, I just named them, the inputs 1 to 4 are 8 to 11. You can change that if you need to, if you have something in the way. For example, 1, 2, 3, 4. And that works fine. The only difference is when you do extra wiring, you have to wire these to those pins 1, 2, 3, and 4. Let me actually undo that. Give me a moment. Let me quickly wire that up myself so you can see an actual working stepper motor. And then when I can actually upload it. If you have any quick questions about the motor or how wiring, just let us know in chat or speak up.
Hey, Andre, can you make me a co-host? I have a picture of the power inputs so they don't get it confused.
Yep. All right.
Okay,
You should be a co-host now.
Yeah. Okay. This is how it should be wired, where the black cable is your ground, and that comes into the minus. And then you should have this little jumper placed across these other 2 terminals, and then this red wire is your positive 5 volts. Because the diagram in the slideshow, it doesn't have all these pins, so I just wanted to make that clear.
Tyler, since you have yours wired up, do you want to actually run it so they can see a working stepper motor?
I don't really have a camera for that, but it is working.
You'll probably just pull it to your camera or move it because mine's a bit blurry.
I literally don't have a camera. My laptop is closed and put away.
Okay. Oh, I see. All right, give me a moment. Let me just finish wiring up, then I can show you how to properly compile and then upload the program to a Nano and then see how it runs. Then we can go over all the code and how that works and how you can change it for different functions. Okay. There we go. Starting with that, as you can see that I have the stepper motor connected to the block right here, power and ground going to these two pins, and then inputs 1 to 4 are going to pins 8 to 11. Now, to run the program, you also have this program in your zip folder I sent you. You just open it up, and then you hit compile. On a side note that this specific program, you're required to download the stepper library. To do that, since a lot of programs require peripherals and need libraries for that to make it easier for you, you have to go through tools and you do manage libraries. That pops up. Then you have an entire list of different programs you need. For example, this specific one for the stepper motor, it is stepper.h. As you can see, that I installed it already. You have to just hit what version you want, hit install, and once that's installed, you can use or call the library for any of the functions. For example, the function stepper would need that, set step, step speed, all uses the stepper library. Once you have the library in, then you could run verify or compile. And it's supposed to say once you're done compiling, it should be done. Once that's done, once you plugged in your Nano to the USB and have everything plugged up, you just hit upload, this little arrow up here. It might take a while, about a minute or so. Come on. Are you gonna upload? Ah, that explains it. I didn't notice earlier, but I accidentally switched the wrong processor. As you can see, that's why it didn't finish loading. So I can switch that back to old bootloader. Make sure that's old bootloader, COM is 9. And then let's try that again. Error occurred. Wait, nope. As you can see, it's done uploading. I can bring up the camera. That's a stepper motor. This program, what it does is it rotates one way clockwise. Then once it's fully done, that is 248 steps or one rotation, and then it flips back counterclockwise. And it's just back and forth and back and forth. Going into our program, we could change that. For example, instead of doing RPMs, we can change that to, let's say 10. That'll speed up the motor to 10 rotations per minute. This type of motor, it has a limit of roughly 15 or so RPMs. They're not very fast. If you want something that's a lot faster, you need to have a DC motor. They are a lot faster, but they have less torque, whereas stepper motors are a lot accurate, slower, but higher torque. So it depends on what you need to use. Something simple like when you make your own clock or a gear-based robot, you can use a stepper motor to drive one gear, which then drives everything else in the system. And for this, we have a delay as well that gives us about 500 milliseconds between each reversal. We can actually change this so it goes 2 rotations, full rotations clockwise, and then it returns to 1 rotation backwards. You should notice that here in the reversal, to reverse the rotation, we have to do a negative sign between steps per revolution. The step per revolution is predefined earlier in 2048. That is the full step rotation, or as I mentioned before, it uses 2-phase to drive the motor. As you can see, if there's an error that occurs, for example, let's say that you forget to include the library, and then you try to compile this. As you can see, there's an error. It says it cannot recognize this function. That is because it's missing something. A lot of information it's missing, it gives you links. It only does. What it gives you is suggestions. Could be wrong if you mistyped it, location where it is. To fix that, you have to go through the code and understand what's missing. Fix that quickly, just reverse it back to stepper and say you forgot to close on the codes. Again, it brings you back here. What this does is the error, the highlight error, it does not highlight the error that you have. It highlights the next step after that. So if you see that a highlight error is here, know that the error is most likely right above that line. And it says right here that expected semicolon before serial. That's before this line here, expecting semicolon to close it off. Now, program-wise, the IDE for Arduino generally understands C, C++. You can also use Python on this. It has a multiple languages you could use, but all of them at the end are translated to machine code. So it doesn't really matter what you use. Most of them are generally in C, more or less. You see the examples online. Does somebody have any questions about the stepper motor, how to drive that, etc.? No? Okay, we can move on. After the stepper motor, I actually wanted to review the LED matrix. As you can see, it has pretty similar things. Here's the actual LED matrix itself, and then here's the driver board. The driver board has 5 different pins: VCC, power, it has ground, and it has data in, then it has chip select and clock. Power, ground is very simple to understand. Data, that's needed to tell the driver which pin or which LED you want on. Chip select, that is telling the chip that, hold on, where's my chat? Sorry, one moment. Oh, you can't open the linked list. Okay. I can send a second email after this video, after this meeting, with a PDF file for you, Kevin. Most of the link list is just giving us a link to all the different parts we bought. For example, we want multiple. We have another product. You can buy the Nanos off Amazon for 3 per. I generally prefer to find the ones with pre-soldered header boards on them, header pins. I found that soldering them it's really annoying, so I just prefer this way. Something with the expansion board, stepper motors, and the LED matrix.
Okay.
There's also, I'm sorry?
Oh, thank you. I didn't know that's all it was.
Yeah, it was just a link between different things you can find. There's also examples of coding, a breakdown of what each thing does. Here's another example of doing this. This specific code example does not use the stepper library. It manually maps each pin to it. Example right here, the lookup table. This was figured out understanding which pins is which motor or which phase is on to turn it. That's just some manual math you can do. Libraries are nice because it means you don't have to do this math. You can just use a library and all the code and the functions are already there for you. It just saves time. For something like this, you don't really need for a stepper motor, but for the LED matrix, it's a lot harder because there's a total of 64 possibilities. And I would rather spend a quick 2 or 3 lines than 64 possibilities to figure that all out by hand.
Thank you.
Let's go over quick some of the links I have. It's just some examples of the LED right here, a breakdown of doing the dot matrix example I mentioned earlier. You can buy multiple LEDs, matrices, and concatenate them. All that is just you have the input, and then output started to the next input, and so forth. I'll explain more in detail. Let me go over the LED matrix. Actually, let's do that now. As I mentioned earlier, for this specific program for the LED matrix, you can use any pins technically to drive the driver forward. However, the Nano has some pins that's specifically meant for certain things. For example, it has what's known as PSI, which is the serial periphery interface. That is more hardware-orientated pins. Instead of going through a software and having higher level to lower level connection, it's more lower level, so it's a faster connection, more reliable. The pins that we use with this program are pins 10, 11, and 13. That is SS, which is, what was it again? That was slave select, yes. What it means, it tells should the chip be on or off, or should it send data or not. The next one we have is MOSI, which is master out, slave in, which means that we have the Nano board sending information to the peripherals, or the slave in this case. There's also MISA, which is master in, slave out. That's the reverse. We have a sensor. You could have the sensor notice if it's light, and then it gives out a data bit or a current to the Nano. You have to put that through pin 12 or MISO. There's also pin 13, which is clock pretty much. It just gives you a clock. For the program that I did, wait, wrong one. I have it to the data in is going as a blue line, going to pin 11. And then you have chip select, which is the inverse of SS slave select, goes to pin 10. Then you have clock to pin 13. As you can see, that pin 12 is skipped. That's because we have nothing going from the item to the Nano. We have only from the Nano to the item. Actually, quickly do that. I'm going to quickly wire up the LED matrix so you can see an example of it working, changing the code, and how to upload that, and any issues with it. While you do that, does anybody have any questions about wiring or how the LED matrix works or concatenate to multiple ones? one thing you should know is, like I mentioned before, you can definitely drive both the motor and the LED off the Nano. However, it's generally not recommended because after a while it's possible to burn out the Nano, or burn out a transistor or resistor like that. For the LED matrix, you can do one of them is perfectly fine. If you want to do multiple matrices, you need to have external power source. That is, don't power it through the Nano, power it through, for example, USB power source. Everything will be the same. It's just instead of having power and ground from the expansion port, the Nano, it'll plug in directly to a USB port. It's just extra protection. If you do that, you can drive multiple motors, multiple LED matrices all at once. Well, that should be good. All right. Look at my camera. I have power and ground right here at 5 volts, and then I have 10, 11, 13. Oh, made a mistake. 10, 11, and 13 are connected to the board itself. If you look on the back of the board, it also gives you a label between what is power, ground, data, chip select, and clock. If we upload, look at the code that I have. Where is it? In the folder that I sent everyone, there's 2 different codes. LED Matrix 1, LED Matrix version 2. Let me bring out the first one. Can everybody see the screen?
I can, yeah.
Okay. As you can see here, there's technically 3 libraries are included. There's the MD Parola and the MD Max 72XX. The MD Parola and the that is the LED matrix itself, the white bit Elisha got, and then the MD Max 72XX, that is for the driver itself. That can be found through the libraries, managed libraries, and your search for Parola, for the MD Parola, and you look for the Max 72XX. Right there. I have both of them installed. You also can do, for example, the MD Max panel. That is usually if you have multiple LED matrices together, so you have one massive LED matrix. You can easily go from something like a 1x4, which is just 4 of them in a line, to something bigger as 8x8 full things. X that out. Once again, just verify and compile it, everything's good. Done compiling, and then you have to hit upload. Then done uploading. Going through here, actually, let me show you it. There. I have the program going through using the MD Parola for most of the functions. That's determining if you want it left or right aligned, if you want to do inverse or right inverse. In both the Nano and the expansion board, there are 2 buttons right here. That is the reset. Second one right here. All it does is just cuts current and then resets it to the program very beginning. It just loops around back and forth. I'll actually show you the code, how that's done. Starting right here, after you have all the, oh, I should mention that as well. I did mention that you need 3 drivers, 3 libraries. The last one, the SPI, that's actually default in the IDE already. So you don't need to download that. It's already in there included. Depending on what kind of driver you get, you have the actual one. We have the blue one, which is the FC16_hardware. That's the default one. That should work fine. Some of the drivers, for example, in this photo right here, this is the generic version. You have to get the second line, which is the generic version pretty much. All I have to do is comment this out and add this instead. You can actually leave this as is with this one as the main line of code. Our original FC16 hardware will work fine with this one. There's no issue with it. Moving on to the next one, this defines the size and the output pins. I gave everybody a single LED matrix, an 8x8. So this just be 1. If you get 4, we just change that into 4. So now you have 4 different lines or 4 total. Go back to 1. And this is the chip select pin. Most of the pins that we use, the SPI, you can't change them except for the chip select pin. I put that as 10. You can easily move that to another pin, for example, 8 or 9. But since we're using SPI, I prefer to keep it as 10 since it's generally faster and more reliable than using a data pin. Just so you know, if you need to, you can easily change it if you have to. Right here, we can see that we're using the MD Parola. That is going to the library. This allows you to determine the hardware type. That is, it's calling into this one, chip pin, and the max devices. So it's pretty much saying use a pin 10 as the chip select, telling the driver you're being used, and the max devices. Going to the void setup, it's just basic setting up your display. Intensity, changing how bright the LEDs are. Zipping up to 15. One of the interesting ways of LEDs, how to change brightness, instead of turning on brighter and lower, one way to do it is to flicker it. For example, if you want to do 100% brightness, you would keep the LED on for the entire period. If you want it to be half bright, you would alternate it. For example, it will be on for, say, 5 milliseconds, off for 5 milliseconds, on for 5 milliseconds, and so forth. That relationship, determining how many times it's on, which is off, changes the brightness of it. Because this chip is roughly 16 megahertz, that means it's going 16 million times a second. So that means that 16 million milliseconds, let's do the quick math. Out of 16 million milliseconds, only 1 million milliseconds will be on, 15 million will be off. If you do, say, 15, full brightness, so you guys can see the difference of it. Hopefully you can see it change. There we go. That is full brightness. That means that all the LEDs are completely on all the time. They are not turning on and off. That's a way to turn the brightness on and off, so it'll be brighter and lower. Bit of a cheat way to do it since LEDs are generally either on or off. There's no way to alternate the brightness of it manually. Like, for example, if you want to do lower voltage, it won't work for that. But the code itself is just a basic loop. All I did is using text alignment. That is from the Parola library file. This just sets where do you want the letter or the image, whatever it is, alignment wise. I had the PA_left. That means this letter L, for example, is going to be leftmost concentrated, then delayed by 1,000 milliseconds, and so forth. I have center-wise. I have the letter C centered, then I have right R, then I have this function here, which is inverting and unverting. I kept it centered as in the middle, the letter P. Then what I did is I had invert. So instead of having the letter itself being on, I have the background on. So it just inverts the color of it. Moving on to another version of the code, LED matrix version 2. This is a lot more interesting. We have multiple LED matrices concatenated. It uses the same thing, same libraries, etc. This is fine. For example, right here is the main difference. If you have 4 of them, I suggest putting 4. You won't have 1 LED, use 1. But the more you have, the more interesting it could be. The specific code, what it does is it scrolls a statement or a letter or whatever across the screen. So you have a very large block of LED matrix together and have a very large screen with scrolling letters back and forth. Once again, it's just using the basic Perl library and the functions, intensity. This function right here displays scroll, which allows you to scroll the letters or the sentences back and forth. I want the word hello to scroll. I have it centered leftwise, and it scrolls left at a speed of 250. That means this hello will come from the left, from the right to the left, saying hello. And then down here, the white loop is just resetting this. There we go. As you can see, if you have multiple matrices, it's actually a lot better than having one. This is a way of using the LED matrix to do cool lettering or videography, that kind of thing. It's more like a, it's like an 8-bit kind of feel to it, but it's fun. If you actually move on, I have multiple lines here, so we can uncomment the hello. If we can do, for example, instead of going left and right, goes up and down. I have the letter X going down. Compile and upload. There we go. Once again, from the function, I have the letter X. The letter itself is going to be centered in the screen. It's going to scroll down from top to the bottom at a speed of 250. There's just different ways you can play around with this and have this. Those are the main code I have actually up here, just some examples so you can see how it works, etc. Do you have any questions about how this one works or how the stepper motor works by any chance? Right, to give you some ideas what you could use these 2 items for. While they're only introductory, when you have more than one, and for example, if you have a separate power source to power both the items at once, we're able to do, you could set the motor to turn clockwise or counterclockwise. Depending on which way it moves, it sends a signal to the matrix, or you send it to a function that tells you which way it's moving. For example, you have it moving at 5 RPMs, and you want to know how fast it's moving, you could send the speed and have that uploaded to the matrix itself and telling you visually how fast it's going, if it's reversing or not. Similarly, like I mentioned before, if you only have one motor, you can do, for those who are more mechanically inclined, you could design different gears and having the main gear sit on the motor itself, turning at a certain speed, and having different gears off that, moving the rest of it. For example, kind of like a basic gear clock, you can do it like that. Or you could do a basic moving robot using a single motor, driving different gears to move forward or backwards. I know not everybody can afford or different parts, playing around with that. That's why there are different programs. If you look at the link list I sent everybody, there's some general information. One of them is where you can find more information on the libraries, how to do tutorials in Arduino. You pull that up, whatever it is.
The other thing I want to bring up is everything we did today, we didn't have any inputs or sensors on the Arduino, and that's what a lot of people use them for, is to basically automate tasks based on certain inputs. So like an example could be like moving a cover on a greenhouse depending on the temperature inside. So that would be something, if you're interested in looking into, you can get different inputs, whether it's like a binary switch, a photo sensor, a thermometer, anything like that. Then you can also set your outputs to act based on your inputs.
Very good point. That brings me to the next part, tutorials and examples. If you look at Arduino's main site, they have a lot of examples of different libraries, how to different code, and how to use the system. For example, right here, as I mentioned before, the SPI explains what each function is, how to use them. Block diagrams, what it means, the rising and falling of it, connection-wise. As you can see here, they were using the Uno. Our specific board we're using is the Nano. However, the Nano and the Uno for Arduino is almost exactly the same thing. The only difference is the Nano is smaller, and then I believe it has 2 more analog pins. I believe it has 8, while the Uno has 6. Besides that, it's literally the exact same thing. So that saves you on space. It's easy to use. We have some examples, some tutorials right here getting started from libraries, foundations. It also brings me up to do different examples. For example, you could use, I know Tyler last year, we tried to do our robotics event for the Micro Mouse for a local competition down in Marion, Ohio. That was canceled because of the pandemic, but we did try to get our members to use Tinkercad. They have a section for not only 3D design, but also for circuits. It's not the most robust system, but it does give you a basis of parts. Instead of the Nano, you can use the Uno. That's what they have here. So you can live program, live connect different parts if you want. For example, you have a photoresistor. This pretty is determining, one of the examples that Tyler brought up is determining how bright it is outside. You can open your greenhouse shed roof on and off. This resistor, for example, be used. If it's light outside, it'll turn on or off. And depending on that, it'll move the roof open or closed. You have different IR sensors, infrared sensors. Then you have ultrasonic. The ultrasonic is one of the ones we used early this year for our Micro Mouse that we bought a ton of to help our Micro Mouse get through a maze. I don't believe everybody finished, but it was one of the things we used. Also ultrasonic, also one of the sensors you can just plug in. Then you also have the keypads. Oh, that's big. You want to do manual input of the keypad information-wise. Different LED strips, DC motors, encoders. DC motors and encoders are actually very useful if you plan to do a small robot. You can determine how much something is moving motor-wise, but then also outputs information back to your Nano or the microcontroller telling you how much it has moved. Saying it moved 1 rotation forward, then it lets the Nano or the microcontroller know that, so then you can use that information to determine pathing or how much it needs to turn or how fast it's going. Yeah. I guess also that. Like I said, this is a very good way to get you started in circuitry and understand different connections and parts using a microcontroller. It's not the most robust, as I mentioned. For example, if you want to do our LED matrix, it's not on here. If you want to do that, you have to code that into it and upload that. There's also other ones. For example, if you go, not that one. Look that up. Circuits.io. This site right here is another version of Tinkercad. That is not what I needed. There we go. Circuits.io app. This is a program where our simulation allows you to, similar to Tinkercad, put down different parts, connect it. This one specifically, you can do the LED matrix like we did in person, but virtually wise. So if you want to do that, remove that, swap that. How many does it have? Arduinos. As you can see, it has about 10 different microcontrollers from this one, the 18 mega 328P. This is actually what we use for our microcontroller itself. This is just bare bones. You can use that for if you're gonna do breadboarding or your own circuit board. If you want something more better or more connected, you can easily do mini or headers. Use the Nano itself. As you can see here, this one is without the header pins on them, so you have to mainly do that. The one we sent you has that, or you can go into the Uno. Like I said, the Nano and the Uno are pretty much exactly the same thing. This one does have pins you can plug in. I look up the LED. That's why. Right here, you have the AP LED matrix. You can add that, and it'll automatically wire and circuit the board to your peripherals. Not only that, is if you do keypad as well, it'll automatically wire that, do the wiring to it. Not only that, you also could actually code it. For example, if you want to do just, come on, the LED matrix, you don't know how to code it, you want an example. Circuit.io does have some example code on there. The firmware information, that matrix.h and the CPP. Like I mentioned before, a max matrix, that's going to be more of a library. And this is what I mean by using libraries. They manually figured out all the pin locations, all the LED pin locations. That is a good, how many is that? About 90 lines of code by 4. That's a good 360 different lines dated to it. But this is just space. This is all giving you the basic characters, letters, punctuations, numbers, backslashes. This is what I mean by using libraries. If it's all on your own, you could find a different library and you just call each individual function from the library. It saves you a lot of time. As I mentioned before, that right here. Come on. See them calling the library they made right here, using the functions. You can download these code, all of them, to your IDE and play around with it if you're not sure how to program it or you need an example. That's one of the pro things about using these simulators. Circuit.io, for example, has different code you can use. gives you an idea how to wire something if you're not sure. Furthermore, if you want more ideas or to use the part we gave you, specifically the Nano, or the Uno if you want to use that instead, has instructables that should be in the link list I sent you. There's examples of the different projects you can do. Like here's the ultrasonic distance sensor if you want to use that. Here's the temperature sensor if you want to do that. Potentiometer, push button. Here's one of the things we actually use our Pacific board for, basic microbot. It just has 4 servers on there, battery, microcontroller. I believe they don't have a sensor on here, but you could easily add a sensor on here, determine if someone's in the way, a wall, then it tells you to turn. You also can add Wi-Fi controller or a Bluetooth controller to connect it to a computer or your phone, like an app telling, make this board move forward. Here's an instruction going through the either Bluetooth or Wi-Fi controller that way. That's more or less what we had planned for this session. Only an hour we had planned it. It's not the most fun event this time. However, I wanted to have a basis for you guys to understand what's possible and have some parts you can run with. The thing about robotics is a lot of it you have to want to do it in practice on your own and just play around with it. I know that next semester we have planned to do bigger events using different microcontrollers and actual build robotic arms, maybe more instructional videos how to do programming or designing 3D models. If you guys do understand how to do or know how to do 3D modeling, we have a 3D printer at campus. If you guys want, just show us an email. We could upload your CL file, print it out for you so you can play around with it. Guys, have any questions? Any recaps, reviews?
Hi, this is Monisha Smalls, interpreter. Monisha is requesting that you please, can you send her the video of the session today?
Yes, I will. We will upload this to our YouTube channel, so it'll be public for everybody. Most likely in a day or two, but also we'll send out an email with the link to everybody in this meeting and the rest of our members.
Okay, thank you.
Of course. Anybody else has questions, comments, or does anybody have ideas for next year or would like to see anything like that? Because we're open right now. I know it's a bit difficult with us being remote and trying to get everything online, virtually, mailing things out, but we're trying. The better you guys are interested, more you guys are interested, the more we can do, more we know what we can do. Okay, if that's everybody, does any questions, I think we can wrap up for now. Thank you for coming, stopping by. I know it's very close to finals and people are busy. We appreciate you stopping by, being interested in this and everything.
All right, thank you, everyone.
All right.
I'm still trying to get the light board set up how you had for the motor, the control board for that, to get the power,
Yes.
the lights on that, the power, and I can't seem to get that. If I show you my wiring on camera, can you tell me what I'm doing wrong?
Yes, of course.
All right. Okay, let me just hold it up. So I have it going from the power there, and then I have it going here. I'm trying to show. I'm trying, and then now that the other board's not lighting up, and I thought I did what you did.
Are you
So
trying
I'm
to do
hold
both
it-
the LED matrix and the motor at the same time, or just the motor?
No, just the motor board.
Have you already uploaded your code?
Okay, so I have to have the code to get this one to turn on.
Yeah,
Yes.
it probably won't light up until you upload your code to the board.
That makes sense. I'll get the code uploaded and then we'll see if that works or not.
If you look at our videos, the file I sent you, there should be also a diagram with all the wiring going to each individual pin that I did. That will correspond with the code I have uploaded as well.
Okay, I'll try that. Thank you.
Of course, thank you for asking. Thank you for being here.
Yep.
All right, I'm going to go ahead and hop off.
All right.